स्टार्ट। यहीं पर रहना और ठीक है, आधे घंटे में ख़त्म करूँगा। लाइव okay. Hello everyone, this is Ashank David and in today's live session, welcome to our Coders Arcade live session for today. And in today's live session we are going to talk about data structures and algorithms. And as you know already, we were covering data structures and algorithm. One live I have already done for it, and that is your vectors live, where I was teaching you about vectors. Now in today's live session is going to be pretty much smaller as compared to the previous live session. And in today's live session we are going to talk about one basic data structure today to start with. When we are starting with DSA, last time I have explained you already of what exactly is data structures and what happens in that, what we are going to cover in that, and we have already seen and understood the roadmap. So if you haven't watched that session yet, I have already recorded that whole live session, and if you have missed that live session actually, then I have already put it in the live session link, where you can see our previous recorded live session, so you can go ahead and watch that as well. Now in this case, today's live session we are going to continue into our data structure series, and today it is going to be pretty much smaller than the previous one, because we are going to only talk about today one data structure. But I will give you an insight of different data structures that we have in this case, which looks similar to this. And because we are actually starting with DSAs, this is going to be the first concept of data structures, where today I am going to explain you how it works, what happens in that, and what all things you can do with this. So let us talk about stack data structure. Guys, stack data structure, let us talk about that. So we have here, we are talking about stack data structure. In DSA we talk about this stack data structure for the first time, and when we are talking about this data structures, this is the first thing that we are going to learn about, that is a stack. What is a stack data structure? So basically stack, first of all, it is a data structure. Let us start. It is a data structure. And what type of data structure it is? It's a linear data structure. Basically we can say it's a linear data structure, where we store the data into a form of stack. The name comes stack. Stack means like one on each other, like this. You might have seen, right? We say book of stack of books. Basically when books are placed on each on another, like that is called as a stack. So stack of books we say. In kitchen we put plates on each other like that. That happens to be called as stack of plates, or maybe stack of something. When we put some items over each other like this, that type of specification is called as a stack specification. So in this case, stack data structure works on the same principle, where we are trying to stack up the data once upon each other like that. Okay, that is called as a stack. And when we are creating and building the stack looks like this basically, where when the stack looks like this stack, you see that it is closed from beneath. That means, let's say I am entering my first element. This is our first element. Okay, as soon as I say first element you enter, it will go directly straight away down at the closed point of the stack. And once this happens here, what happens? If I say next one more element you put, that next element goes directly above that. And once we are able to directly put it above that, even if you can push more and more and more and more elements until it happens to be fully filled like that, you can do it. But let us say I am saying now delete one element. As soon as I say delete one element, the latest element will get deleted here first. This latest element gets deleted from here. So you observed here that the topmost element which was right here, this one got deleted first. This element got deleted first basically, which makes us one configuration of first in, last out. Okay, first in, last out. You got my point? What is this first in, first, last out? You see, this was the first element, right? You saw this was the first element. The lowermost element was the first element, right? So you entered that element first. But because now the other elements are getting over on top of that, that first element will come out last. Because the latest element which got entered will come out first. So this concept and this process is called as first in, last out. The element which went inside first will come out last, or in short form we say philo. Philo, we say philo for first in, last out. You got my point, everyone? Now, if we open this by chance, if we open this from beneath, then it will become Q data structure. But Q data structure is a different kind of data structure, where the data is put upon like that, like how in stack is used to be. But then the stack is, when you open the stack from both the sides, that becomes a Q data structure. Well, Q data structure is something very important for us to know about, which we will not discuss in this live session because it has its own things and variables to discuss about. But in today's live session, let us only discuss and focus on stack data structure. So in this case, this is how your stack data structure looks like, and your stack data structure is closed from beneath. Well, this makes the configuration works like first in, first out. Okay. Now this is the logic that I have explained you. Now this is the theory basically. The main programming logic now I am going to explain you now, and then we will code for it. So let's understand how to code for it. First of all, I need to understand this thing. If I want to implement first in, last out, then to implement this concept, I need some base data structure or collection where I can store my data, and then later on I can change that data to mimic in working like how stack works. For example, the idea is very simple. How do you code? To code it, you need to first write its algo, and we're gonna do that here first. So basically, first in, first out we are saying, no? I said this is gonna be first in, first out, first in, last out, sorry, last out. Okay, first in, last out. So to make this configuration work, I can have a array. I can have an array, and this array, let's say I have some random numbers array. Basically, let's say index 1, 2, 3, 0, 1, 2, 3, 4, 5 and 6. I said these are my indexes, and I said that this is my array. Now I said I want to implement the concept of first in and last out. How to do this? Basically, by default, you don't have a stack data structure on itself. It is dependent upon the other type of predefined collections that we have already in our programming. There can be multiple ways you can implement the stack, but the very easiest and the simplest way is, and the basic way is going to be your array implementation. So today I'm gonna take this array and then I'm gonna implement it as a stack. There are multiple other implementations also of stack that you can use. That is, for example, you have array that we are doing right now. The next type will be your linked list type. That can be done later on. Once we cover up the linked list concept, later on we can come back and we can do linked list in stack, and then we will see another various different ways are also there. We will talk about that later on. But today let us understand about the very first concept of how using an array you can implement the concept of first in and last out. Okay, how to do this? Let us see. So now example, imagine you have an array like this and you want to implement the concept of first in and last out. The concept of first in and last out says that if this is your stack and this is your elements stored inside this, let's say there are two elements, this is element 1 and this is element 2, and if I want to implement the concept of first in first out, if I remove any elements, this element gets removed first, meaning this is the first element which did not get removed, it will be removed at the last because it is the first one who went inside. This is possible because this stack is closed from beneath. To implement this concept here in this array, I need to have some configurations first. I have created my creation of the array. So there we go, we have an array already created into our program. Now I want to implement this concept of first in first out. How we will do this? Let's see. So guys, the idea goes like this, that I can create a variable called as top. Okay, top. Why I am taking as top? Because you see, the default inbuilt functions which are useful in arrays and which are actually used are, there are 4. Number 1, we have push operation. Number 2, we have pop operation. Number 3, we have top operation. And number 4, we have empty operation. Okay. These are the major 4 operations that we have to perform in any stack. Without push, you cannot enter any element. Push is going to push the element into the stack. Pop will delete the element from the stack. Top will give you the topmost element of the stack, which is exactly this one. Topmost is the latest element which got entered. So basically this is the top. You got my point? This top variable will allow us to pick which element is on the top, which will get deleted first. Understood my point? Because in this case, latest element is getting deleted first. So top will return me the latest element which got inputted into the stack. Understood? And then I will check for if this stack is empty or not. To check it, we can write a Boolean function called as empty. I hope so that you have understood this really well. Now let us go ahead and understand how this can be done easily. So we are using this array and this array is empty right now. That means Q is underflown. Underflown means it is empty. Okay. So I have a top variable which will be returned in the function for top. These are all functions, by the way: push function, pop function, top function and empty function. Push function will allow us to add an element to the stack. Okay. Pop function will allow us to delete the element from the stack. Top function will allow us to take out the latest element inputted in the stack, and empty will tell us about the stack if it is empty or not. I hope so that this is very much clear. So now let us see. So here imagine, to implement the concept of first in and last out, I said that I will have a top variable like this, and I will initialize this top variable to -1. Why -1? Because indexing starts from 0 in array, and if I make sure that top is at -1, we make sure that the stack is empty or the array is empty. This will mimic the way to tell us that if the stack is empty or not. So I can return straightforward. You can imagine now that in the empty function, if top is equals to -1, then we can say return true. If the function empty is Boolean, and yes, it will be Boolean. That we'll talk about later on, but we got the idea for empty. Top, if I want to get the top, I can return the ARR of top, because top is what? Index. So if I want to return the topmost element, I will return the ARR of top, and that will return me the topmost element. You got my point, everyone? In this case, because top is top is actually the index here, if I want to push the element, if I want to write the push function, what will be the logic here? Push logic would be increment the top plus plus, and using the array notation ARR of top, put the value if in the parameter of push value is provided, int val. You got this, everyone? This is the push function. The idea is very simple here. The idea is way too simple, and the idea is that I will move this top like this plus plus, and using the array notation I can put this notation, I can put the number right here or whatever it is, the element. You got my point? Again, if I want to push, again I will say that top plus plus and ARR of top equals to val. That is the logic. That is the push logic that we have done. Alright? And now I said I want to do pop. So if I want to do pop function, if I want to do pop function will not take up any parameter. I can just say decrement the top and over, so top minus minus, that's all. I hope so that this is very much clear. So what I am going to do here is that we are saying that top you just decrement and this will get deleted automatically. You understood basically? Well, what I am doing here is that push is allowing me to push all the elements, and top is the latest most element which got added. And when I pop, I will just say top minus minus, hence first in last out got implemented automatically in the array. And this is how you implement the stack using the array. I have already written the program for you so that I can explain you directly on the board without wasting any time. So let's move on to that. Right? I hope so that this whole logic is clear to everyone. Right? Now, let us go ahead into the code and understand how it is done. Right. So right here we are into the code, and you see that this is a C++ code that I am going to show you here, and we are going to understand how it works. So first of all, first thing first, I have done hash include IOStream. You already know about this, using namespace std, basic C++ we already know. This is a macro substitution preprocessor directive which I have created. I will show you why I have done that. But I have created a class called as a stack. Now we are using object oriented programming, guys, here. So I started creating the class, and the name of the class is a stack, and I said that in the class stack the attributes are going to be, there are two attributes. One, an array pointer where I will dynamically allocate the memory and create the array later on. So I have created a pointer. This is just a normal pointer. I am just going to use the DMA here. I will dynamically allocate the memory. If you are doing C programming, you use malloc, calloc. If you are using C++, then you use new. That I have done here, right here. I am going to explain you that very soon. So I have started by creating the array pointer and the top variable. As you already know, we have just now discussed about this top variable, and using in the public section of the class, I created the constructor of the stack class, and inside the constructor of the stack class, we have initialized the array with its memory. What did I said just now? We are gonna create an array type of pointer, and this pointer in this pointer, particular pointer, I am going to allocate the memory. To allocate the memory, I can use this new keyword, and as soon as I say new keyword, I'll have to give the type of what memory I need to allocate. So I said int. And what is this n? N is the macro substitution preprocessor directive which I have already created. So in this program, before the compilation starts, the memory will be allocated before even the code goes to the compiler using this macro substitution preprocessor directive. And we have already covered macro substitution preprocessor directive in our preprocessor videos. So if you haven't watched that, I'll give the link in the description so that you can later on go ahead and watch it for yourself. Or you can just search directly on YouTube Coders Arcade preprocessor directive. You will get our video where I am teaching about what are the 3 types, and all the 3 types I have covered. So you can go ahead and check it. It's an interview question which is asked, so please make sure that you do it. Without wasting any time, let's move on further and understand. So here I have allocated the memory, and after allocation of the memory, the size is taken using the macro substitution preprocessor, and now I have initialized the top is equals to -1 as we have discussed about earlier. We are saying top equals to -1 means array is empty right now. Now I started writing the push, pop, delete, all those functions, and let's start by push. So I said void push, and this is the parameter which I have taken here, and now I have said that I need to check for if the overflow condition is maintained or not, because if overflow condition or the stack is already full, how you will be able to enter an element? You can't, right? So you need to make sure that the stack is not full. To check that, I can check if top is equals to -n-1. Top is the iterator which we are using in this case, and if that iterator is already at the last element, that means the array is full, and if the array is full, that means the stack is getting overflown. So if top is equals to n-1, see out stack overflow and then return nothing. I hope so that this function, this part is very much clear. It's damn easy. Then I said top plus plus, as we discussed, we said top plus plus, and using the array notation I said ARR of top equals to the x. X is the parameter of push. Well, I hope so that you have understood this also very well. Now this is your push function for the stack using arrays. Now I said we'll do pop. In pop, unlike push, we checked for overflow condition in push. In pop, we will check for underflow condition. What is underflow? Underflow means if the array which you are trying to delete the element from is already empty. If it is already empty, you can't delete any element. That means it is underflown. This scenario, this condition is what you call as stack underflow condition. And to check for this, if top is at initial point, that is below 0, that is -1, I can say stack is empty, and you can't delete or pop anything out from that stack. There you go. So if top is equals to -1, then see out no elements to pop or stack underflow, and this is how you will check for the stack underflow condition. In this case, this is your pop function, and you will just say top minus minus, which will actually delete the element. Actually not, but now it is not visible. So it is deleted basically in this case. These two functions working will make sure that the concept of first in and first out is maintained. First in and last out, sorry, first in and last out is maintained. And the major two functions are done. The top function, of course, if you are returning the top and if stack is already empty, there is no top to return. So in that case, again the same condition will be copy pasted here for underflown, and if top is equals to -1, then of course this. And now you see guys that here the top is having the return type as int, right? So you can't just write something like return nothing, because void was pop was void, but in this case top is of return type int. So you have to return -1 here. Right? You can return something else like int min or int max or numeric limits, but that's something advanced we'll talk about very soon as we are progressing into our DSA course. But as of now, this is the thing. And if you want to return the top, you will say return ARR of top will return, and this will return you the topmost or the latest element into the stack. Well, I hope so that you are clear with this. The next thing is going to be the last one, bool empty. If the stack is empty, then it will return true or false because it is of type boolean. The return type is boolean. So this function will return a boolean value. So I said return top equals to -1. I just wrote this condition here. I wrote this expression here. If this expression is true, it will be typecasted automatically, implicitly, and automatically it will return me a true value. If it is not like true, it will return me false. And so that is how easy it is. This is how easy it is to do a stack data structure. And that's done, guys. Now this is something extra that we usually don't do, so we are not going to discuss, but I'll provide the code for it. You usually do not print the stack. By default, you can't print the stack, right? There is no such function called as print stack. So this is on one of the students' demand. We wrote this function, but it is not the actual function, guys. There are only 4 functions, that is your push, pop, then top and empty. These are the only 4 functions which are there. But if you want to see print stack, you can see the print stack. Anybody can do the stack print, but you have to iterate over the elements, and you already know how to print the stack. Okay. If you want to do a search also, then this is an extra search function. I'll provide the code for this on later on in the description below. And we have written our main function right here, and I have said we started by creating the stack object because stack is of course a class in this, right? So I said that stack, we created the object, and then using that object I said push 1 2 3 like this, and then I clicked on to top. So it will give me the topmost element, which is 3 right now. So your output will look like 3 like that. And then I said pop, so 3 will be popped, top will be 2, then I said pop, so 2 will go, 1 will also go, and this will print a stack under flow, and this will return true. Understood? So if I uncomment all of this and I uncomment this part and then I run this program, you see that here first it prints 3, then no elements to pop, and then 1. But I hope so that you have understood this really well. If you have any doubts, you can ask me. Otherwise, we are going to end this live session now, because this is it for in today's live session. I hope so that you have understood this really well, and yep, this is your DSA today's live session, and I hope so that you have understood this really well. Okay, this is your stack data structure, guys. Thank you for watching, and that's all for today. In the next live session, I will be covering hues and other things to be covered. Later on we will see. So do not forget to like, share and subscribe to our channel, guys, and thank you so much for watching. I hope so that you are doing well. I'll see you guys in the next one, and that's all for this video, guys. Thank you so much. I'll see you